Okay, so currently I'm on the project that we created in the last video named Java, and before we move on to the actual big topic of this video, I'm simply going to review everything that we learned from the last video. In the last video, we learned all about variables. First, how to declare variables, and second of all, how to change the values of variables. Just to review that, first, declare a variable. The structure is data type, and then the name of the variable followed by an equal sign, and then the value of your variable followed by a semicolon. To change the value of your variable, the structure is pretty similar. You want to reference the name of your variable followed by an equal sign, and then the new value of your variable followed by a semicolon. In today's video, we're going to be learning about all the different types of data that you can store, or all the basic types of data, primitive types of data that you can store in variables. Now, we'll also be learning all the different types of data, which are the same types of data that you can store in constants, which are variables whose values never change. Now, there's one last thing before we get into data types, which is what constants are. Now, this wasn't introduced in the last video. However, constants are just variables whose values don't change. So to declare a constant, you basically just declare your constant like a variable. However, you simply want to add final in front of the entire declaration. So that's just a little bit of an introduction of what constants are. Okay, now on to data types. Today we're going to be learning about all the different primitive data types in Java programming. These are going to be the building blocks for more complex data types such as dates, etc. Now, there's two different ways to distinguish data types. The first way is by what type of data you're going to be storing inside of your data type, and the second way is by how much memory by default your data type is going to store. Now, for now, you don't need to worry about this. However, in the future, just be wary that it exists. Each data type has a default memory that it's going to take up. Okay, so let's start on reviewing all of these, or learning all of these data types. The first data type is Booleans. Booleans store true or false only, and they take up 1 bit. So if I were to declare a Boolean, I'd reference a Boolean by the data type Boolean, or by typing Boolean, and then let's say yes, and then true. Now the only other value that say yes could have is false. The second data type is bytes. Bytes are numbers in the range of -128 and 127, and they take up 8 bits. And you want to reference byte by byte, and then let's say score, test score. Next, we have characters. Characters store characters, and they take up 16 bits. Now, to reference or have a variable that is of type character, you want to write char for the data type, and then your variable's name. And when you write the value, you want to type in your value and then put single quotes around it. This lets Java know that you have a character as your value. Now, if I didn't have these quotes, then Java would give me an error. Just a little thing to remember. On to the next data type, which is doubles. Doubles are numbers with decimals, and they take up 64 bits. Usually doubles have a 15 decimal place precision. So now on to floats. Floats are also numbers with decimals, but they take up 32 bits and only have a 5 to 6 decimal place precision. Now, one thing to know is that Java will give you an error when you just write a decimal as a float's value if it includes decimal places. And to fix this error, you just need to write parentheses float in front of this value. The reason is Java can't quite distinguish if this value is a double or a float. So just remember to add this in front of the value to let Java know that this is a float. Next, we have integers. Integers are whole numbers and they take up 32 bits. Usually you're going to be using integers as your default data type for numbers. Let's say 100. Next, we have longs, which are huge whole numbers, and they take up 64 bits. Now notice though, even longs have a limit, so they can max out. So just remember that each data type do have their limits depending on how much memory that they take up. And now on to the last data type, which is shorts. Now shorts are smaller whole numbers, and they only take up 16 bits. Okay, so here are the examples of all the basic primitive data types that you're going to be using in Java programming. Now there's one other data type that I want to talk about, which is strings. Now strings are strings of characters, and they're technically not primitive because they're made of characters, and also they're not primitive. So, however, you can technically treat strings as primitive even though they aren't. Java does let you treat them as a primitive data type though, technically, because strings are so commonly used and there's no other data type that is primitive that you can use to write words and sentences and paragraphs, etc., or strings of characters. So to declare a string, you just want to write string with a capital S. This is one of the ways that distinguishes primitive data types. Primitive data types always start with not an uppercase letter, with a lowercase letter. But anyways, to declare a string, you'll just want to write string with a capital S, and then let's say name equals with quotes, double quotes, and then your value inside. So name here. Okay, so now that we've seen all of the primitive data types and strings, there's one more thing that I want to share with you, and that thing is a connection between numbers and characters that you just want to be wary of. Now let's say we just define an integer. Now, as I stated in the last video, for every variable, the values of the variable, they always need to say the data type that you set them to originally. Now, there is an exception with characters. If we set a number, say an integer or a long or a short, to a character, there will not be an error. And the reason is characters are in the computer expressed as ASCII, which means that they're technically numbers beneath the surface. So just note that Java will not give you an error if you set a character to a number or a number to a character. And that's about it for this video.